everybody. All right, so let's start this math lesson. Today is lesson 20. Take out a piece of paper that has these notes on it. Either you got it from the front or your friend got it for you. Today's topic, brand new unit called Introduction to Expressions. All right, so there's vocabulary on the board. This is our vocabulary we're going to be using throughout our unit, so please feel free. Do me a favor and copy them down into your notes. Make sure you have all of the definitions. So copy them down right on your handout, and I'm going to read them as you are copying. All right, so a polynomial is an expression in which consists of one or more terms. Standard form of a polynomial has terms placed in descending order from largest exponent to smallest exponent. For example, if I have x cubed and then followed by an x squared term plus followed by x term plus 5. So x cubed plus x squared plus x plus 5, that would be in standard form in order from largest exponent to smallest exponent, and then our constants. The degree of a polynomial is the highest exponent of any term. So in the example I just said to you, x cubed would be the highest exponent, so that polynomial would have a degree of 3 or a power of 3. Okay, then we have leading coefficient. Again, we've talked about the word coefficient before, but the coefficient of the first term when it's written in standard form. So in my example, the coefficient of x cubed, which is the highest power, has a coefficient of 1. So that would be considered the leading coefficient. Term. A term is a number or a variable or a product of numbers and variables, and terms are separated by addition or subtraction signs. So in my example, x cubed plus x squared plus x plus 5, there would be 4 terms because there are 4 things that are being separated with addition or subtraction signs. And then finally, like terms are terms that use the same variable with the same exponent. Okay, make sure you have all that copied down, and we're going to do some examples together. All right, here we go. So the terms, how many terms are there in this expression? Good, I can see why you'd say that there are 3. There's 4e, there's 7e, and there's 5. So that would be considered 3 terms. Cool. All right, next one, like terms. Which of these are alike? Again, read your definition. Like terms use the same variable with the same exponent, so they are alike. They are like each other. Good. 4e and 7e are like terms. What about coefficients? We've talked about this word coefficient. Coefficient, co-worker. We work together, so we work with the variable. So that'd be 4 and 7. And then finally, constants. Constants are always going to represent the same number no matter what, and that would be 5. 5 will always be 5 in this expression. 7e will vary. That's why we have a variable next to it. It varies depending on what the value of e is. All right, let's try these on your own, number 2. Giving wait time for students to complete. All right, so terms. How many terms does this have? Good, it has 3 terms, 5a, 2, and 7. Now, I'm going to tell you it needs to be -7. It needs to be -7 because that minus sign, we can rewrite it as the addition of a -7. Even though I don't like to see that, but when I separate it by terms, I'm going to take the sign with it. So there are also 3 terms here. Make sure you take the sign if it is negative. Obviously, I'm taking the sign here. It's positive. You just don't see the plus sign. Like terms, what is alike? What could I add together if I wanted to? I could add 2 and -7. Coefficients, what are the coefficients here? Good, just 5. And the last one, constants. What are the constants? 2 and 7, but remember we're going to change that to -7. Okay, so now let's talk a little bit more about actually adding like terms together. So here's a problem. I'm going to work it out. I want you to copy down the steps while we do it. So the first thing I'm going to do here is I'm going to look at this problem and I'm going to identify and circle the like terms. So 2x is a like term, and the other thing that is alike with 2x is 3x, but I'm going to also include the signs. So I'm going to take that circle and I'm going to expand it a little bit to include that plus sign. Now, this will be really, really important when that plus sign is a minus sign because it will totally change what I am combining together. Instead of 2 and positive 3, it'd be 2 and negative 3. Just like we did above, identifying it as a negative number if there's a minus sign. Okay, once I identify and circle the like terms, I am then going to, you'll hear the word combine like terms, which really means add the values. We're going to add the coefficients. So I'm going to add 2 and 3 together because it's positive 3, and I'm going to get 5x. So 2x plus 3x makes 5x. And then my final answer will be my final step will be to rewrite the expression in standard form. Again, if you're not remembering what that was, go up here to our notes. Standard form has terms placed in descending order from largest exponent to smallest exponent. So I have 5x, which has an exponent of 1. So I'm actually going to add that in just so you can see it. Again, we don't normally see the power of 1. And then I'm going to write the plus 5 at the end. But again, if this was like a multiple choice question, you would see just it written this way. But I wanted to show you that the exponent of 1 is better than an exponent of nothing, which is what 5 has. All right, so do me a favor, do all of this page, finish this page on your own. And I'll be walking around to see how you are doing. Giving wait time, walking around. Oh, nice job. Oh, good. Oh, wow, you got all these done pretty quick. All right, so you know what? Why don't you just keep going? There's harder problems on the next page. I just want you to work on those for now while you're waiting for everyone else to finish. All right, guys, so now that we're done, everybody's just about done. Period's about to end. Let's wrap this up. Let's talk about the answers. So answers here. John, good. 2x plus 6. Allison, good, but that needs to be in standard form. Sam, can you write it in standard form? Good. I'll change that negative sign to a -1. Excellent. Allison, next one. Good. And last one on this page. Ashley. Fabulous. All right, so I didn't have a chance to go over these, but if you did them, feel free to show me whenever you get a chance. And let me hand out your homework. Homework questions 1 through 10. They're going to look just like the ones we did. Feel free to look over your notes and look at the steps to help you complete them. All right, guys, great job today. Everyone, so we're going to start Introduction to Expressions today. Everyone got a packet. I just put you all into groups based on the cards that are in the envelopes in front of you. I would like you to sort them into groups. I'm not telling you how many groups there are. I'm just asking you to sort them into groups. Obviously, there should be something alike about your cards if they are in groups. I left you 4 boxes. You don't need to use all 4 boxes. Maybe you want to use 3 or 2, or maybe you decided that you want to make 6 or 8 groups. Feel free to split the boxes in half. When you and your team feel like your groups are settled, I want you to fill out this chart with your groups, number them 1 to whatever, however many groups you have, and then explain the groups that you made. There are sentence starters on the board. Feel free to use those to help you explain your groups. For example, one of the sentence starters says, all of the cards in group 1 have blank, or group 2 is different because blank. Feel free to use that as I circulate the room to talk to you about how you're doing. Okay, some conversations maybe. I'm walking around the room. Oh, I noticed that you put this 0.8x with this negative 0.4x. But you moved in a different group. You put 1/3 x in a different group. Why did you decide to put these into separate groups? Oh, I noticed that you put 2 in the same group as 2x in the same group as negative 2y. Why did you decide that? Oh, I noticed that you put these all seem to be negative. Is that what made you decide? Oh, why did you decide to put the negatives together or all the positives together? Why did you decide to put these numbers separate from these numbers? Why did you decide to put the ones with this letter in this group and this letter in a different group? Okay, giving time for students' groups to work, maybe taking note of which groups had which things for me to talk about. All right, before if everybody has their work shown on their paper and their explanations down, leave your groups where they are, and let's do a quick gallery walk. While you're gallery walking, I want you to take notice of anything that you thought was unique or different than your thinking, so we can share it out. Giving them time to walk around. Okay, let's share out some group observations. What did you notice? Oh, and you notice people had separate groups based on fractions and decimals. Another group had positives and negatives together. Some groups had positives and negatives separate. Oh, very nice. Some people combined based on the numbers that they saw. Other people combined based on the variables or letters that they saw. Excellent. Okay, so now to learn more about this concept, we're going to use our Freyer models, and we're going to dive a little deeper into the vocabulary. So on your packets, you have polynomial vocabulary Freyer models. Most of them have examples and non-examples filled out. What I want you and your new groups to do is I want you to come up with the characteristics and facts box and maybe some sort of working definition. You can talk your way through it. You don't necessarily have to write it down. If you feel like your group is comfortable, designate somebody to go up to the room, in the room where that Freyer model is, and I want you to lift it up and read the definition. If you feel like it's a good definition, bring it back to your group and share out. If you feel like you need to go over and take your packet and copy it down, that's fine, and share it with your group. So I'm giving you about 10 minutes to do this. Actually, I'm giving you about 7 minutes to do this. And I'm going to take a group over here at the table. Again, completing non-examples, facts, and characteristics, writing their own definition, or going and looking at the definition on the board. Again, the directions for this activity would be on the board. Okay, let's come back to our group. Anything unique about our definitions, characteristics, or facts, or something that you felt might not have been 100% clear, or a question that you think somebody else might have a question on? What do you think was the trickiest term that we've talked about? Why do you think terms is the trickiest one? Good. Explain a little more about that. Yeah, why would an example look like it had 3 terms, but it only had 2 terms? Can somebody explain why that's true? How that's possible? Yes, there are some like terms in there, and if once I combine those, or I can add 4 and positive 5 together, I would then only have 2 different terms or 2 types of terms in that expression. Nice job. All right, let's move down. Again, a little quick refresher. This visual should help you remember exponent, constant, coefficient, and variable. If not, feel free to go back into your notes and find your Freyers on those terms. All right, so let's talk about this. Identifying the like terms, coefficients, constants. Partner with the person sitting next to you and fill these 4 boxes out. We'll come back and talk, and then independently you will do number 2. All right, let's talk about terms. How many terms could there be? Okay, what do you think? Okay, so John thought 2 and Josh thought 3. Who wants to break the tie? Who wants to make a decision? Who's right here? Sahib, who is right? Okay. Explaining that 3 could be a correct answer, but 2 could also be a correct answer. Good. So I'm going to list all 3 terms right here. 4e, 7e, and 5 as the 3 different terms, but some people might say that there are 2 types of terms here. Which ones are alike? Which ones are like terms? Andrea. Good. How did you know they were alike? Excellent. Okay, moving on. Coefficients. Which numbers are the coefficients? Alex. Sam, do you agree or disagree with Alex's answer? Can you explain? And why did you know that? Good. So coefficients here, using Alex's words, are the numbers that are in front of variables that show multiplication. The coefficient would be 4 and 7 here. 4 and 7 are the coefficients. And then finally the constants. Brandon. Okay. And Jacob, what do you think about that? Okay. Good. So you agree, constant, because it's a number that will constantly be the exact same amount. It will always be 5. All right, let's take a moment to work this out. And I'm going to have you write one of the answers on the whiteboard paddle in front of you. While you're doing it, I'm going to hand out these whiteboard paddles. All right, so I'm going to decide to ask you about the like terms. What are the like terms? Write them on your whiteboard paddle and hold your paddle up when you're ready. Keep your eyes facing front. Okay, so I see 2 and 7, and some of you I see 2 and negative 7. I notice nobody put 5 or 5a down, so that's good. I'm going to agree. The two things you have on your paddle are like terms. The question is it 2 and 7 or 2 and negative 7? Who wants to give some clarification to that? Okay, it is 2 and negative 7. We're going to take that minus 7 and represent it as a negative 7, especially if we're pulling them apart separately. Okay, so terms, again, how many terms could there be? What 2 answers could possibly be correct? Alyssa? Yes, there could be 2 terms, there could be 3 terms, depending on how you're looking at the problem. Explain why there would be 2 terms then, Alyssa, because I can see 3 pretty clearly. Good. So there could be 2 or 3 terms. And again, I'm going to use that negative sign as my minus. So 5, 2, and negative 7. Coefficients. Alexa. There's only one. Coefficient is 5. And finally, the constants. Mark. Here we go, 2 and negative 7. All right, so to represent these, we're going to use something called algebra tiles. It's just a visual representation of these types of terms. I will put it up on my website. There is a online version of this, a digital version of this. It's really kind of cool. You can change it from positives to negatives. And so we're going to use this as an example when we're talking about it. So I'm going to use it on here, and I'm going to talk about it on your handout. Again, your handout, notice the tiles do not have the x's and x squareds and 1s and negative 1s on them. So anytime you see it, you can use the poster up on the wall that has these visuals on it for you to refer to. Anytime I put it in a handout, obviously you won't see the color because the handouts are not in color, but the labels will be there for you so you know, is it a positive x or a negative x? Okay, so let's talk about the number of hours somebody worked. Obviously, we don't know how many hours Hugo worked, so somebody decided to call it the variable x. Okay, but now I want to represent that in a numerical form. So taking it from a physical form and moving it into a representation of that. So how many are there? It's just x. What's another way that would also be acceptable if you wrote it? Anthony. Good. 1x is also another way to represent x. Both are correct. All right, so now how about this Patricia's hours? I have these 2 x's here, and I have 1 and another 1 and another 1 over here. Brian. Good. I love how you said it was 2 x's. So I'm going to write that as 2x. And then I have 3. So what do I do with the 3, Brian? Right, it wouldn't be 2x3 because that doesn't make sense. It's 2x and you said and 3. So what mathematical symbol would be that? Good. And then finally, let's talk about sun's hours. How would I represent that? Tara. Carla, do you agree or disagree? Because? Okay, good. Makes sense to me. Yeah, seems right. All right, so now total, what would the total hours be? So now I'm going to switch here to my model so I can model it with you. Now we're talking about like terms. Remember, we can only combine like terms. So I'm going to group all these like terms together, noticing the shapes are alike. This is what makes them like terms. So now how many of these do I have? You're right, I have 4. So I have now 4 x's, and then over here in my algebra tiles, now what's interesting is I have positives and negatives. What happens if I put a positive 1 and a negative 1 together? They become 0. Whoa, look how cool that is. I put them on top of each other, they cancel each other out. Well, it seems to work with positives and negatives. Not great, but okay. So a positive 1 and a negative 1 cancel each other out to get 0. If I borrow $1 from you, negative 1, and I give you $1 back, positive 1, what changed? Absolutely nothing. So I'm going to put that positive 1 and that negative 1 together. These guys are called a 0 pair. I'm going to cancel them out, and I'm left with positive 1. So my final answer, 4x and, right, and 1. 4x plus 1. Nice. All right, so now using the tiles in front of you or between you and your partner, I want you to set up this problem here, and I want you to decide what the final answer would be after you combine the like terms. Walking around the room, giving some time, giving some prompting, realizing that some students already know what they're doing, probably don't even need the models, were able to come up with the answer themselves. Hey, John, you know what? I see that you're doing pretty well in this. Doesn't seem like you might need the models. So why don't you skip over to set B? You can show your work in the middle and work and do your final answer here. Come up with some tips in terms of showing work so that people definitely get the right answer. I'm going to come back and check with you to hear some tips and advice because I'd like to share those out at the end. All right, everybody. Again, if you're feeling comfortable right now, after we went over this, your final answer here should be 5x plus 5. Nice job combining the 2x and the 3x together. If you're feeling comfortable, you can go right to set B on the back of this page and work on these. You can work on these with a partner or by yourself. You feel like you need a little more practice, you want to start off a little bit slower, you're getting a little more comfortable, you can start with set A, again, with a partner or by yourself. Walking around, letting students ask questions, work together. If students are if they're starting on A and they seem to do well, I would tell them to stop and go right to set B. If they're on set B and maybe they're struggling, I'd set them back to set A. If I had time at the end of the class, maybe I would go over the answers, maybe I wouldn't based on what was around, maybe I would just give the answers online. And your final activity for today is going to be plickers. So take out your plicker, you can put your packets away, and answer these questions. So here's the first one. What is the leading coefficient? Second one, what is the constant? Third, what is the power of the expression? Okay, hold up your cards, going over the answers on plickers. If you haven't used it yet, I'll share it with you in class. All right, so again, if you are done, now I have where we're at. It looks like the statistics are showing that we're doing pretty well with our vocabulary. Your homework tonight is going to be 5 questions and 1 error analysis question. So your choice on the 5 questions. The right side is going to be a little more challenging. The left side is going to be a little easier, just like side A and set B on your packet. And then everybody has to do the error analysis question. I did the work, you find the mistake. All right, guys, great work today.